Okay, so welcome back to tutorial 7. I apologize for not being able to do an online tutorial. I have a problem with my Wi-Fi at home, so I had to borrow someone else's place to upload the video and stuff. So I couldn't do an live tutorial. So please bear with me until my Wi-Fi gets better. I promise we'll try to do an online tutorial. Now, without further ado, let's move on to our first question. So the tutorial for this week will basically revolve a lot about using tables to identify the properties of the water. Now, for question 1a, a 10 meter cube tank contains steam at 270 degrees Celsius and 15 bar. The tank and its contents are cooled until the pressure drops to 1.2 bar. Some of the steam condenses in the process. Now A. What is the final temperature of the tank contents? B. How much steam condensed in kg? And C. How much heat was transferred from the tank? Now, so we have 10 meter cubes and n moles of steam, which is B, vapor, steam, at 275 degrees Celsius, 15 bar. And then it condenses, so you still have the same volume of water, but now they are in equilibrium with two phases. One is vapor phase, one is liquid phase. And now it is at 1.2 bar, in which it is saturated. So for part A, we want to find the final temperature. It's very simple. So look at your table B6, okay? So we are given pressure, the final pressure is 1.2 bar, so simply refer to the pressure here, 1.2, and then refer to the temperature here, which is 104.8 degrees Celsius. That gives you your final temperature. Now, to find the total mass of water, we need to identify the because the final water here is in vapor and liquid phase, so we need to find the specific volume for each phase. Right? Okay, so so the water goes in because it is at superheated. So go to table 7, okay, so you can obtain your specific volume of your superheated steam from table B.7, taking 270 degrees Celsius, which is between here, and at 15 bar, which is between 10 bar and 20 bar. So you have these information here. So how are you going to find your specific volume at 275 degrees Celsius and 15 bar? Is that we need to do double interpolation. So we need to interpolate 2 points here, and then interpolate the point between the points where we found our interpolated specific volume here. Alright, then so we know that mv plus ml is equals to 55, also 55 kg, and min, after we convert the volume of the water to kg using the specific volume, we get 55 kg. So what goes in must come out. Okay, this is just condensation. So you will have mv plus ml equals to 55 kg. Then we can use the volume to do the balances, which is v, the volume at vapor phase, and the volume at liquid phase is equal to 10 meter cube. So convert this as well, in which we need to multiply the mass of your vapor coming out with its specific volume and the mass of the water in liquid phase coming out with specific volume. So we can obtain this from table B6 at pressure 1.2 bar, which is these two values here. Okay, substitute it in. So we have equation 1 here and equation 2 here. We can simply solve it simultaneously to solve for MV and ML. Okay. Now for part C, we were asked how much heat was transferred from the tank. So what is Q? Now we know that Q is the delta U. Okay, so we can find the specific internal energy of the water in vapor and liquid phase. Okay, now so delta U is out minus in, right? So this is a total energy balance equation. So we already found MV, ML, and we also have M in here. U in. Okay, so we can obtain all of the U here from the table also, table B6 for UV and UL, and from table B7 for U in here. Okay, using this. So we need to perform interpolation also. Sorry, I think the box that I circled is wrong. It should be the one below. This is for the internal energy. This one was for the one above. Anyways, then simply substitute your values in and solve for your Q.